Hi guys, welcome back. Today we're going to talk about converting repeating decimals to fractions. So to begin with, I want to talk about what a repeating fraction is. Repeating means that it will go on over and over and over. So for example, you might have 0.3333333. We denote that with a line over the top of the number that's repeating. So in this case, I don't have to write all the threes. I just write one and put the line to show. I might have a situation where I have two numbers repeating. So this would be 2, 4, 2, 4, 2, 4, 2, 4, 2, 4. The line is over the 2 and the 4. Another situation you'll run into is you might have the first number or second number be unique, but then we have a 4 that's repeating, 4, 4, 4, 4, 4. So the line is only over what repeats. That's important to keep in mind. Let's go ahead and we'll get started with sample 1. In sample 1, I have a situation where x is equal to 0 and 5/10, where the 5 is repeating. And I want to know, how can I write this as a fraction? Now I can approximate it by putting it over the tens place, but I want to know an exact fraction. So that's what we're working on today. So I think about my different rules when it comes to solving equations, and one of them is that I am allowed to multiply both sides of an equation by the same number, and it doesn't really change anything. So in this case, I see that there is one digit that's repeated, and so I'm going to multiply by 10. The reason I'm multiplying by 10 is so I can move this over to the whole digit place value, and I'm going to remind myself that it's 10 because there's one number under the repeating line. So there's 1 0. That's just a trick in my head. So I'm going to do 10 times x equals 10 times 0, 5/10 repeating. What I'm left with is 10x equals, when I move this over 1, remember I have another 5 here? Because it's repeating, I'm still going to have a 5 repeating there. Because every time I scoot it over, I'm just going to get another 5. That didn't go away. So I need to make that repeating go away. How do I do that? I am going to subtract by x equals 0.5 repeating. So these are equal, which means on this side I can take away that x, and on this side I can take away 0.5 repeating. Does that make sense? They're equal, so I'm taking away from both sides. What am I left with? 10x minus x equals 9x. 5.5 repeating, take away the 0.5, and I'm left with 5. It's a little tricky. Now, again, I'm allowed to do the same thing so long as I do the same thing on both sides. So this time I'm going to divide by 9. I'm trying to isolate my variable. So whoever's with the variable, the x, that's what I'm dividing both sides by. So divide on the left, divide on the right. What I'm left with, 9 divided by 9 is 1x, and 5 divided by 9 is 5/9. Now I have a fraction. I personally like to take out my calculator and check my answer. So on my calculator, I'm going to put 5 divided by 9, and I get 0.5555555. So I know I'm right because now my answer and my problem all match. Let's try a second sample. Go up a bit here. And let us try sample 2. Let's let x equal 0.26 with the 6 repeating. All right, so the first thing that I notice is I'm going to multiply by 10. Because there is one digit under the repeating line. So that gives me 10 times x equals 10 times 0.26 repeating. Okay, so 10x equals, that's moving over one decimal spot, right? So 2.6 repeating. I know I am allowed to subtract from both sides. Subtract by x equals 0.26 repeating. So I can take that away on this side. Take that away on that side. I'm left with 9 on this side. And on this side, it's a little difficult to see. I'm going to go ahead so that when I do my subtraction, I'm going to put that other 6 here, right? So what do I have? 6 repeating take away 6 repeating is 0. 6 take away 2 is 4. And then 2 take away nothing is 2. So 9x equals 2.4. Now I want to isolate my variables, so I'm going to divide by 9 on both sides. I'm left with x equals 2.4 over 9. Technically, this is correct. We do not typically have decimals in fractions. So I am going to multiply by 10 over 10. This is just 1. So the identity property says I can multiply. I'm going to multiply this by 10 over 10. And what I'm left with is 2.4 times 10 is 24. And 9 times 10 is 90. So this is a more proper. This isn't wrong. It's just not proper. So let's go ahead and we'll get our calculators. We'll clear them out. And let's see if our 24 divided by 90 does equal 0.2666666. So we know we're correct. We checked it.